Hello, math friends. 3.2, we are reading Add Integers, our learning objectives. By the end of this section, you will be able to model addition of integers, simplify expressions with integers, evaluate variable expressions with integers, translate word phrases to algebraic expressions, add integers in applications. Be prepared. 3.3. Before you get started, take this readiness quiz. Evaluate x plus 8 when x equals 6. If you missed this problem, review example 2.13. Simplify 8 plus 2 times 5 plus 1. If you missed this problem, review example 2.8. Translate the sum of 3 and -7 into an algebraic expression. And if you missed this problem, review table 2.7. Model addition of integers. Now that we have located positive and negative numbers on the number line, it is time to discuss arithmetic operations with integers. Most students are comfortable with the addition and subtraction facts for positive numbers. But doing addition or subtraction with both positive and negative numbers may be more difficult. This difficulty relates to the way the brain learns. The brain learns best by working with objects in the real world and then generalizing to abstract concepts. Toddlers learn quickly that if they have 2 cookies and their older brother steals one, they have only 1 left. This is a concrete example of 2 minus 1. Children learn their basic addition and subtraction facts from experiences in their everyday lives. Eventually, they know the number facts without relying on cookies. Addition and subtraction of negative numbers have fewer real-world examples that are meaningful to us. Math teachers have several different approaches such as number lines, banking, temperatures, and so on to make these concepts real. We will model addition and subtraction of negatives with 2 color counters. We let a blue counter represent a positive and a red counter will represent a negative. If we have 1 positive and 1 negative counter, the value of the pair is 0. They form a neutral pair. The value of this neutral pair is 0, as summarized in figure 3.17. So here we have figure 3.17. A blue counter represents +1. A red counter represents -1. Together, they add to 0. Manipulative mathematics. Doing the manipulative mathematics activity addition of signed numbers will help you develop a better understanding of adding integers. We will model 4 addition facts using the numbers 5, -5, and 3, -3. So here you have 4 sets. You have 5 plus 3, -5 plus -3, -5 plus 3, 5 plus -3. So example 3.14, model 5 plus 3. Interpret the expression 5 plus 3 means the sum of 5 and 3. Model the first number. Start with 5 positives. Model the second number, and we add 3 positives. Then we count the total number of counters, and that's 8 positives. So the sum of 5 and 3 is 8. Okay, so we got a couple try it problems. Example 3.15, we are modeling -5 plus -3. Interpret the solution. So here, -5 plus -3 means the sum of -5 and -3. Model the first number. We start with 5 negatives. So here we have the red circles. Model the second number, and that's adding 3 negatives. Count the total number of counters, and you'll find 8 negatives. That is 8 red markers, so a total, the sum of -5 and -3 is -8. Some try it problems. Example 3.14 and example 3.15 are very similar. The first example adds 5 positives and 3 negatives. Oh, excuse me, 5 positives and 3 positives. Both are positive. The second example adds 5 negatives and 3 negatives, both negatives. In each case, we got a result of 8, either 8 positives or 8 negatives. When the signs are the same, the counters are all the same color. Now let's see what happens when the signs are different. Example 3.16, model -5 plus 3. Interpret the expression. -5 plus 3 means the sum of -5 and 3. We model the first number. Start with 5 negatives. And we were modeling this with 5 red circles. And now we model the second number. Add 3 positives. These are the 3 blue counters. Any pairs become 0. They are neutral, so we remove any neutral pairs, and we count the result, which is 2 negatives. So here the sum of -5 and 3 is -2. Notice that there were more negatives than positives, so the result is negative. We got some try it problems here. And example 3.17, model 5 plus -3. So very similar, we begin with interpretation. Interpret the expression. 5 plus -3 means the sum of 5 and minus 3. Model the first number. Start with 5 positives. Model the second number. Add 3 negatives. And you can see again, we neutralize pairs. That is, they add up to 0. Remove any neutral pairs. Count the result. And we have 2 positives. The sum of 5 and negative 3 is 2. Positive 2. We have a try it problem. Example 3.18. Modeling addition of positive and negative integers. Model each addition. Here we have A, B, C, D. For A, we start with 4 blue markers, add 2 more blue markers. These are add 2 positives, and we count the total, giving us 6 blue markers, and so 4 plus 2 is 6. For B, minus 3 plus 6, start with 3 negatives, add 6 positives, remove neutral pairs. And how many are left? 3 positives. So minus 3 plus 6 equals 3. For C, we start with 4 positives. We add 5 negatives. We remove neutral pairs. And how many remain? How many are left? Minus 1. D. Start with 2 negatives, and we add 3 negatives. How many do you have? 5 negatives, that's negative 5. Okay, so this is a good way to model adding integers. You'll notice expressions here. This is also a type of modeling. So there are many ways, or there can be many ways to represent mathematical expressions or statements. And if you keep studying math, you may even represent this graphically. In a way, this is a kind of graphic. But these models help us understand what's going on in what is trying to be communicated. Couple try problems. All right, simplify expressions with integers. Now that you have modeled modeled adding small positive and negative integers, you can visualize the model in your mind to simplify expressions with any integers. For example, if you want to add 37 plus negative 53, you don't have to count out 37 blue counters and 53 red counters. Picture 37 blue counters with 53 red counters lined up underneath. Since there would be more negative counters than positive counters, the sum would be negative because 53 minus 37 equals 16. There are 16 more negative counters. Let's try another one. We'll add minus 74 plus minus 27. Imagine 74 red counters and 27 more red counters. So we have 101 red counters all together. This means the sum is minus 101. Look again at the results of example 3.14 to example 3.17. 5 plus 3, both positive, they sum positive. Minus 5 plus minus 3, both negative, sum negative. When the signs are the same, the counters would be all the same color, so add them. Minus 5 plus 3, different signs, more negatives. So they sum negative. Here, 5 plus minus 3, different signs, more positive, so they sum positive. When the signs are different, some counters would make neutral pairs. Subtract to see how many are left. Table 3.1, addition of positive and negative integers. Example 3.19. Simplify A, 19 plus minus 47, and B, minus 32 plus 40. Solution. A, since the signs are different, we subtract 19 from 47. The answer will be negative because there are more negatives than positives. 19 plus minus 47 is minus 28. B, the signs are different, so we subtract 32 from 40. The answer will be positive because there are more positives than negatives. So here you have it written out as an expression. Got a couple try it out problems. Example 3.20. Simplify minus 14 plus minus 36. Solution. Since the signs are the same, we add. The answer will be negative because there are only negatives. Minus 14 plus minus 36 is minus 50. The techniques we have used up to now extend to more complicated expressions. Remember to follow the order of operations. Example 3.21. Simplify. Minus 5 plus 3 times the sum of negative 2 plus 7. Solution. Simplify inside the parentheses. Minus 5 plus 3 times 5. Multiply. Minus 5 plus 15. Add left to right. And so we get 10. Notice that you work inside the parentheses first, and then outward. Evaluate variable expressions with integers. Remember that to evaluate an expression means to substitute a number for the variable in the expression. Now we can use negative numbers as well as positive numbers when evaluating expressions. Example 3.22. Evaluate x plus 7 when A is equal, well, sorry, A, x is equal to minus 2. B, x is equal to minus 11. A, evaluate x plus 7 when x is equal to minus 2. What we do is we substitute everywhere we see an x, we substitute in minus 2. So you have that here, minus 2 plus 7. Minus 2 plus 7 simplifies to 5. And B, evaluate x plus 7 when x is equal to minus 11. Substitute minus 11 for x. So we get this expression. Simplify. Think about those counters, and we get minus 4. Few try it problems. Example 3.23. When n equals negative 5, evaluate for A, n plus 1, and B, minus n plus 1. Solution. So here for A, evaluate n plus 1 when n equals minus 5. We'll substitute in minus 5 for n, simplify, and just like our counter model above, minus 5 plus 1 is equal to minus 4. B, evaluate minus n plus 1 when n equals minus 5. Substitute minus 5 for n. That becomes minus 5 plus 1. Simplify and add, and you get 6. Some try it problems. Next, we'll evaluate an expression with two variables. Example 3.24, evaluate 3a plus b when a is equal to 12 and b is equal to minus 30. So we have two variables, a and b. Substitute 12 for a and minus 30 for b. So we do that here, you get 3 times 12 plus minus 30, multiply 36 plus minus 30. 3 times 12 is 36. Minus 30 follows through, becomes minus 30. And we add, we get positive 6. Some try-it problems for you to try at home. And example 3.25, evaluate x plus y squared when x is equal to minus 18 and y is equal to 24. Solution. This expression has two variables. Substitute minus 18 for x and 24 for y. Substituting, we get minus 18 plus 24 squared. Or you could say something like the sum of minus 18 plus 24 squared. Or you can maybe say this squaring of the sum of minus 18 plus 24. Or perhaps square minus, well, let's leave it at that. Add inside the parentheses. So when you sum the inside, we get 6. simplify that square. 6 times 6 is the interpretation of 6 squared, giving us 36. And a few try it problems. Translate word phrases to algebraic expressions. All our earlier work translating word phrases to algebra also applies to expressions that include both positive and negative numbers. Remember that the phrase the sum indicates addition. Example 3.26. Translate and simplify the sum of -9 and 5. Solution. The sum of -9 and 5 indicates addition. The sum of -9 and 5, translate. That's -9 plus 5. And when we simplify it, thinking back to the counters, or if you're applying some other model, you should get -4. All right, a couple triad problems. Example 3.27, translate and simplify the sum of 8 and -12 increased by 3. The phrase increased by indicates addition. The sum of 8 and -12 increased by 3. Translate. So first we organize the 8 and the -12 inside the parentheses. The increased by 3 goes outside, well, in this case, the bracket. They call this the bracket. Oh, this is the bracket. Oh, where is it? Okay. That is the bracket. There's just no way to highlight without getting all of it, but that is the bracket. Simplify. We simplify the inside of the bracket. 8 plus -12 is -4. The -3 on the outside, you notice, does not change. And we add, getting -1. Couple triad problems. And we add integers in applications. Recall that we were introduced to some situations in everyday life that use positive and negative numbers, such as temperatures, banking, and sports. For example, a debt of $5 could be represented as -$5. Let's practice translating and solving a few applications. Solving applications is easy if we have a plan. First, we determine what we are looking for. Then we write a phrase that gives the information to find it. We translate the phrase into math notation and then simplify to get the answer. Finally, we write a sentence to answer the question. Example 3.28. The temperature in Buffalo, New York, one morning started at 7 degrees below 0 Fahrenheit. By noon, it had warmed up to 12 degrees. What was the temperature at noon? Solution. We are asked to find the temperature at noon. Write a phrase for the temperature. The temperature warmed up 12 degrees from 7 degrees below zero. That means -7 plus 12. Simplify that, and we get 5. Write a sentence to answer the question. The temperature at noon was 5 degrees Fahrenheit. This is table 3.2. Very good. Some try problems. Example 3.29. A football team took possession of the football on their 42-yard line. In the next 3 plays, they lost 6 yards, gained 4 yards, and then lost 8 yards. On what yard line was the ball at the end of those 3 plays? We are asked to find the yard line the ball was on at the end of 3 plays. Write a word phrase for the position of the ball. Start at 42, then lose 6, then gain 4, then lose 8. Well, there were no thems in between here, but you get the idea. Translate to math notation. 42 minus 6 plus 4 minus 8. Simplify. When we complete this from the left to the right, we get 32. Write a sentence to answer the question. At the end of the 3 plays, the ball is on the 32-yard line. And this is table 3.3. We have a few try it problems that you can try at home. Couple. Media resources and many exercises for you. Okay, this makes chapter 3.2, add integers. I encourage you to practice some of these problems, reference the examples above, and get comfortable reading and interpreting these problems. Because many of these ideas will repeat itself. They'll show up in some form or another, and so it's good to think about some of these things now. And that is chapter 3.2, add integers. All right, math friends, thank you very much.